Good day, everyone, and welcome to week 4 of the differential equations class. Here is the plan for today. And today we have a quite exciting topic. We are going to learn the fundamental theorem of differential equations, which is the Picard and the Love theorem. So it tells us that the initial value problem for a differential equation always has a unique solution. So in order to understand today's lecture, you are going to need material from calculus. So please make sure that you, well, if you don't remember, please review the stuff, continuity and differentiability of functions of several variables. So this is from calculus 3. Well, recall that in week 2 we have learned how to solve separable equations and how to solve linear equations. So these are some classes of differential equations that can be solved explicitly. These classes of differential equations overlap, right? So basically we have all possible first order differential equations, right? So each differential equation looks like y prime equals some expression in t and y. Then if this right hand side satisfies certain properties or is of some particular form, then we may have either a separable or a linear differential equation. Then both of them can be solved explicitly, but these classes overlap, right? So that there exist differential equations that are at the same time linear and separable. Well, and then when you think of differential equations, it is good to develop some intuition in terms of the initial value problem. And I like this example a lot. So this is a picture of Akatsuki probe. So it is a space probe that Japan Space Agency sent to Venus. So what happened to it, to the Akatsuki probe, is that it was supposed to enter the orbit of Venus, but then its engine broke. And of course it happened when it was approaching Venus. So and since the engine broke, it couldn't enter the orbit, and it just proceeded, and then it orbited the sun instead. Well, what the Japanese did is a very clever thing. So they waited for 5 years until Akatsuki probe, I mean, it was orbiting the sun, and Venus, the planet Venus, was also orbiting the sun. But then it's just eventually, in several years, the Akatsuki probe approached Venus again. And then they injected it to the orbit of Venus by using the spare engine. Well, but from the mathematics point of view, what we have here is whenever celestial bodies or probes or they are moving, if there is no force other than the force of gravity, then the motion is governed by a certain differential equations that comes from the law of gravitation. Well, but at the same time, when we want to apply a force to it, so in this case it means when we switch on the engine, then we apply the force. It means that initially we are given it a certain acceleration, right? So the probe is at a certain position, say x of t, right? And when we give it certain, apply force to it, then by applying acceleration, we change its initial speed, right? So if what we know is that its position at certain point, so it is a certain position, and then dx dt at t. The initial speed is given by, well, by burning the fuel. But once the fuel runs out, the probe is just moving on its own, When it is moving on its own, it does so when it is doing so, so that it satisfies its motion satisfies a certain differential equation. So in other words, so here in order to do this maneuver, they had to find a good initial condition for the differential equation, so that the solution of this initial value problem is going to correspond to the probe orbiting Venus rather than the Sun. And they did it successfully, but my point being is that differential equations are designed to describe some motion, right? And such motion is always going to be continuous. And the main reason for a differential equation is that we want to solve an initial value problem. So whenever it describes a certain real process, it's not just the differential equation itself, but the initial value problem and the product.